All right, 10. So I got a request to um, about question number 8. So here goes. This is question number 8 on the review package unit 4 review assignment. So a hot air balloon is hovering 80 meters above a lake. A man in a boat moving in a straight line spots the balloon and measures the angle of elevation to the balloon at 65 degrees. 25 seconds later, he measures the angle of elevation at 25 degrees, and you have to determine the speed of the boat. So if we draw ourselves the diagram. So we know that there's a man in a boat and he's traveling on a straight line. And we know that our boat, whilst he's on the boat, he sees a balloon that's 80 meters up in the air. Um, we know that he sees it twice, right? He sees it once when he has one angle of elevation, and once when he has another angle of elevation. So the two angles of elevation in which he sees the boat are 65 degrees and 25 degrees. So we should remember that the closer we are to the object, the bigger the angle, which means that the 65 degrees is going to go here close to the 80, and then the 25 degrees would be further away. We know that he's traveling this distance here from when he first spotted it to later in 25 seconds. So we need, in order to be able to calculate speed, if you remember, speed is equal to distance over time. We need to be able to calculate the distance, and we already know that the time is 25 seconds. So in order to be able to do this as a two-part problem, we know that, well, first we know that in order to calculate this distance, we want to use this triangle. So let's see if we can figure out some more of our angles. So this angle here, it's going to be 180 minus 65 degrees. So we're going to do theta equals 180 minus 65, which is equal to 115 degrees. So this angle is 115 degrees. And then this angle up here in the triangle, we'll call it beta. That's equal to 180 minus 115 minus 25. And so that's going to equal 40 degrees. So we'll plug 40 degrees in here. So now if I look at this triangle, I have three angles and I have one side, but I don't know what this side is. I don't have any other information, so I need to know at least one other piece of information in order to be able to solve for the distance. And it can be either of these sides. I'm going to go ahead and do this side. So I need to calculate this side y. So if I know this side, I can do y over sine 25 equals d over sine 40. So the question is, can I calculate that side? Well, I look here. I have this nice small right angle triangle with 65 degrees opposite and hypotenuse. So I can use the sine ratio. So I know that the sine of 65 degrees is equal to opposite, which is 80, over hypotenuse, which is y. So I'm going to rewrite that in terms of y. So I know that it's 80 divided by sine 65. Remember, when this crosses the equal sign, it becomes a multiplication. And when this crosses the equal sign, it becomes a division. So now I'm going to quickly grab my calculator and do the calculations on that. So I'm going to do 80 divided by the sine of 65. And when I do that, I get 88. 0.2702. So y is going to equal 88.3 approximately. My next step then, so now that I know this, I can use the sine law to calculate d. So I'm going to just quickly separate these out here so we can actually make sure that we don't confuse them with what's already going on. So I'm going to d over sine 40 is equal to y, and my y is 88.3 over sine 25. So then I know that d is going to equal 88.3 times the sine of 40 divided by the sine of 25. So I'm going to get my calculator. It still has my answer from before, so the 88.2702. I'm going to multiply that by the sine of 40, and I'm going to divide that by the sine of 25. And when I do so, I get 134.2 or 134.3. So again, my answer is 134.3. So now I know that speed is equal to distance divided by time, and I know my distance is 134.3 and my time is 25 seconds. So when I plug that into my calculator, I already have the 134.3 from before. I'm going to divide that by 25 and I get 5.37. So my speed is 5.37 meters per second. And the reason that it's meters per second is that this was measured in meters. So I have 134 meters divided by 25 seconds. And so just to reiterate, I drew my triangle. I knew the balloon was 80 meters up in the air. I knew that when I first saw the balloon, I was that the person could see an angle of elevation of 65 degrees, and then the angle of elevation was 25 degrees. And so I ended up with this triangle. Knowing that I only knew the 80, the 65, and the 25, I then calculated the two other angles in this triangle. Once I had the 115 and the 40, I knew that I needed to know a side and an angle and a side and an angle. So in this case, I chose to solve first for angle y. I used SOHCAHTOA and did sine of 65 equals 80 over y. Rearranged the equation to solve for y and got 88.3. Then I could use this triangle and use the sine law. So I'm going to do d over sine 40 equals y, which was 88.3 over sine 25. Plug that into the calculator. Got 134.3, and so now I know speed is equal to distance divided by time, so I get 134.3 divided by 25, and I'm left with 5.37 meters per second. Hope that helps.